So in Chapter 9, we will talk about fluids. So in order to talk about fluids, let's start from the very basic idea of what a fluid is. Fluid is any object that is easily deformed by external forces. Fluids could be liquids or fluids could be gases. A liquid will flow to take a shape of the container that will hold it, whereas a gas will completely fill this container. Gases are compressible and can easily change their shape, whereas liquid is incompressible. Its volume is fixed and it is impossible to change. So pressure arises from the collisions between the particles of a fluid with another object, for example, with the walls of a container. So the momentum change or impulse that is away from the container wall, there must be a force exerted on the particle by the wall. So for example, if there was a particle that comes in here, a gas particle, it hits the wall and rebounds back. So there will be a momentum conservation and there will be a momentum change and all of those fun things that we've been talking about as this progresses. So Newton's third law says that when an object hits the wall, there is a force on the wall due to the particle. So the pressure then is defined as force per unit area. So the force that something applies on the wall of the container, in this case, times the area over which that force is being applied. So the units of pressure are newtons per meter squared. As you can tell from this equation, force is in terms of newtons and area is in terms of meters squared. And in general, they are called pascals. One other thing that you need to be very aware of is an atmospheric pressure. That is, the normal units that people use are called atmospheric pressure, or ATM. And that is equals to 101.3 kilopascals. So basically the idea is it's 1.01 times 10 to the 5 pascals. These conversion units are very important to remember. So as an example, if someone steps on your toe, exerting a force about 500 newtons at an area of 1 centimeter square, what is the average pressure on that area in atmospheres? In this case, he says that someone steps on your foot and exerts a pressure of 500 newtons on the area of 1 centimeter squared. And it's asking me how much pressure will you feel? Okay? So this way, I know pressure is force per unit area. This is given in centimeters, so what do I have to do? I have to convert. And not only is this given in centimeters, it's given in centimeters squares. So I have to convert it into 100 centimeters into meters, but squared, right? So that means I have to divide it by not 100, but 100 times 100. That means my answer is going to be 0.12341 meters squared, okay? And if I have that as an answer, I need to plug that in. So 500 newtons divided by 0.00001 meters squared. And my answer comes out to be 5.0 times 10 to the 6 pascals. That's a huge number, newtons per meter squared. Okay, that's huge. But it asks me what is the pressure exerted on that area in atmospheres. So how do I go from pascals to atmospheres? So in this case, what I will do is 5.0 times 10 to the 6 pascals times, I want atmospheres to remain at the end, and I want pascals at the bottom. So 1 atmosphere is equals to 1.013 times 10 to the 5 pascals. So if I calculate that, that is going to come out to be about 49 atmosphere. So one person stepping on your foot with 500 newtons is this equivalent to 49 atmospheric pressure. That's large.